come to this fossa. Fossa has triangular shape or pyramidal shape form. Base of fossa look to down and laterally, tip of the fossa look to up and into the medially. By the way, tip of this fossa located between two bones. From superficially it is clavicle, from deep it is the first rib. So using these three triangles, supraclavicular, clavipectoral, pectoral, and subpectoral, we divided axillary fossa into three portions to describe the topography of the structures. Again, I promise you, in the Friday, all these questions I will explain you after. That's in the last triangle, in subpectoral triangle, our plexus brachialis presented not by trunks, but presented by cords. From anatomy, I think you study it, that it has three cords. The medial cord, which is located medially to artery. Lateral cord, laterally, and posterior cord, which is behind of the artery. What is the difference between the cords and the trunks? Cords give the final branches of plexus brachialis, which we call long branches. Trunks gives the short branches, which is mainly goes to the thorax region and to the shoulder region. Long branches goes to the free upper extremity. That is the difference between them. To say, remember please, the source of innervation, it is plexus brachialis. Again, from anatomy, let's quickly remember all long branches. Medial cord gives two skin nerves, nervus cutaneus brachymedialis and antebrachymedialis, and gives the biggest branch, which we call nervus ulnaris. Ulnar nerve, it is the biggest branch of the medial cord. Also, it gives the medial root for nervus medialis. That is the branches which is originated from medial cord. Lateral cord, two branches. Lateral root of nervus medianus and nervus musculocutaneus. These two roots in front of the axillary artery join to each other and they form the nervus medianus. So nervus medianus has hard structure. It is originated from two roots. One is come from medial cord, another come from lateral cord. They join to each other and they form the nervus medianus. Finally, we goes to the posterior cord. You can see two branches here. From these two branches, one is exceptional. Nervus axillaris, why it's exceptional? If you will compare it with another long branches, it will goes not to the free upper extremity, but it will come to the shoulder girdle. It is come to deltoid region, where it is located in subdeltoid space between the humeral joint and between deltoid muscle, and it is innervated the deltoid muscle. By foramen quadrilaterum, if you remember, it is passed to the backside, from axillary region, back wall of your axillary region, which is presented by four muscles. Latissimus dorsi, teres major, teres minor, and the subscapular. It has perforations. These perforations, you can see it in this picture, for example. One has triangular shape form, it's located inferiorly and medially. We call it foramen trilateral. Second has quadrangular form. It's located upper and more laterally, and we call it foramen quadrilateral. And this yellow structure, it is nervus axillaris. By foramen quadrilaterum, it is leave the axillary region and come to it. But generally, that is not my question now. My question is to remind you source of innervation. Again, I tell you, this is plexus brachialis. Source of supplement. Source of supplement. Source of supplement of your upper extremity. This is the continuation of your axillary. That's a continuation of subclavian artery. We call axillary artery. It is located in axillary region. Continuation of axillary artery we call brachial artery. That's a subclavian artery located in the neck. From midpoint of the clavicle, behind of the clavicle, it is entering inside of the axillary region. Below the clavicle, we rename it, and we call it arteria axillaris. That is the main artery, which is supply upper extremity. Arteria axillaris become to the free upper extremity, and in the level of the upper border of arm region, we rename it. And we call it arteria brachialis. Arteria brachialis projected strongly by direction of the medial groove of the biceps. By the way, in axillary region, it is projected by imaginary line, which is connecting the midpoint of your clavicle with uppermost point of your sulcus bicipitalis medialis. Or by Piragov, we can project it by the anterior margin of the hairs in the axillary region. Remember about it. And let's continue. Now finally, I enough remind you the structures inside of the upper extremity. Now the break time, yeah? Okay, we'll make the break. To be ready to draw for your cross sections. Why I will make the break? Not because I need it so much, because now all the students will go to outside, and here will be very noisy. Let's make the break, and after the break we will continue. Okay, from 2 o'clock up to 10 minutes past 2. Yeah, it will continue. Yeah. And our lesson is continuous up to 3. This side will be lateral, that side will be medial. Let's write the letters element and let's say this will be the cross section. You look from downwards to upwards. They say usually, guys, in the cross section, interior structures is shown like upward. Posterior structures like lower, but in reality it is not the superior inferior, it is anterior and posterior, because that is the cross section. Start to make the picture. First black line which I drew here is of course skin. That is the skin. Little bit about specificities of it. A minute attention, guys. Skin is unique because in both extremities, by the way, not only in upper extremity, in the medial surface we have skin which is thinner, which is more elastic, which is more movable, and vice versa. In the lateral surface we have thick skin, which is less elastic, which is less movable. Generally, all the skin in extremities is elastic and movable, but then we compare the medial surface with the lateral surface, we'll see that medially it is much more thinner and movable. Why it is? Because as I say before, lateral surface is not so much protected. That's why we need the thick skin to prevent any traumatization of the lateral surface. Medial situation is enough. It is closed surface, it is protected surface. Of course, we don't need to have so thick structures, yeah, for the protection of that. 1 minute.